In example 6, we've been given the root function as 2 square root x minus 2 plus 3. But really, we're going to just ignore that for now and deal with that afterwards. We can deal with the transformations and the root functions separately. And with the transformations, we can look at the x's completely independently of the y's. So looking at the x's, here the transformation is 1 left, then horizontally compress 1/2 towards the graph's original center. So I've written here in red, this is left 1 compressed by half. Now this is the actual description of what we're doing, but we want the function notation. So a couple things we can do. There's one way we can do this, is we can just undo this. Okay, so we're going to end up with times 2 plus 1, and then this represents the notation. This is what we're actually going to put into the function notation. So that's one way. An alternative way of doing this is to rewrite the expression, and so that we have our transformation done as compression first and then shift last. Okay. Now, if we do compression first and shift last, we can put this into our function notation in factored form. So those are two different strategies we can do. We're going to end up with two different looking solutions, but they're actually going to end up being the same. So when I put it into my function notation, it's going to look like this. Y equals f, and then all that notation is going to look like this. So I can do it, in fact, I'm going to make this smaller because we're going to have two different solutions here. So one solution is going to look like this. Y equals, this one's going to come from here, f bracket, and then we're just going to plug in the notation that we figured out algebraically, 2x plus 1, and that's it. That's our solution, because that is going to be, we undid the actual transformation. And then finishing this off, we're going to look at the y. The y is easy. The change in y is times 3 first, and then plus 2 after. Okay, so that's one potential solution. The other solution comes from here. So because this is, again, my description, this is what actually happened. I'm going to compress by half first, then shift. That order is the factored form order. So when I write this in factored form, I just write this in factored form. So this is in factored form. I'm going to have my compression first. Okay, so I'm going to times 2 first. And then I'm going to shift left. So I'm going to go plus left 1/2. So it's going to be plus 1/2. Okay, and it's going to look like that in factored form. Now, looking at the blue and the red, if you actually get rid of the brackets in the blue, we'll end up with exactly the same expression as red. So they are algebraically exactly the same. So the transformations are exactly the same. They're just using two different strategies. One is just undoing this expression, and we don't have it in the order that we typically want it, and we put it the red expression in, or we can actually rearrange the original expression, the transformation, so that it happens. So what we did is from here to here, we got rid of the brackets to make it compression first, shift last, and then interpreted that in factored form. So the answer here would then be doing the y transformations on the outside, times 3 plus 2 just to complete it. And these are the two of the same solutions. They look different, but they are the same solution.